Welcome to a new lesson. In this lesson we'll be discussing mixed and entire radicals. So let's define what mixed and radicals are. On the left we have an entire radical, while on the right we have a mixed radical. They are equivalent, but the entire radical has a coefficient of 1. We don't write the 1, but it does have a coefficient of 1. While a mixed radical has a coefficient of that's not 1. Let's take a look at an example. Simplify each radical. The word simplify means that change it to, so change it to a mixed radical. I'm going to show you a fairly simple way to change any radical into a mixed radical. So let's take a look at root 80. Make sure you identify what's the index. The index is 2. It's not written as 2, but it's always referred to as a square root when there is no index written. We're going to do a prime factorization of 80. So 8 times 10 is 80. And we're going to break it down to 2 times 2 times 2 and 2 times 5. Now since it is an index of 2, this means that we're finding groups that have the common number, and in each group we'll have 2 units. That's what the 2 identifies, as groups of 2. Of 2. It doesn't mean it has 2 inside the group, it just means it has 2 the same numbers. From each group, we'll take out one of the 2's. And then we'll write the root. Anything that's left outside the groups, we'll write it inside the root. And then we'll multiply the individual numbers outside the radicals together. So we get 4 root 5 is equivalent to root 80. On your calculator, you can check your answer. Now we'll do the next part. Cube root of 144. 144. Again, we're going to prime factorize. It's 12 times 12, which is 2 times 2 times 3 times 2 times 2 times 3. Since now we have an index of 3, we're looking for groups of 3. So groups of 3. So we have, I'm going to rewrite this so it's quite visible. We're going to put all the 2's together. So we have 4 2's, and we have 2 3's. So the only group of 3 we have is we have 3 2's right there. So from this group, we'll take out a 2. We'll take out a 2, and we'll put a cube root, and anything that's left behind from other groups, we're going to combine them together. So 2 times 3 times 3. So our answer is going to be 2 cube root, and 2 times 3 is 18. And here's your answer. This means that the mixed radical for cube root 144 is 2 times cube root of 18. Last but not least, 162 and of index of 4. So let's find out all the factors of 162. And I'm not sure what our exact factor, so we'll just divide by 2. So 2 times 81 is 162. So that's 2 times 9 times 9, which is 2 times 3 times 3 times 3 times 3. Since the index is 4, we're looking groups of 4. And in this case, we have a group of 4 with the 3's. So again, we'll take one of the 3's out. We'll put the radical with the index of 4. And anything that remains that's not in a group, which is in this case is 2, goes inside this radical. And this is equivalent to 164 to the root of index of 4. You could check with your calculator. Let's take a look at a different example. Now again, the question asks, write each radical in simplest form. Now simplest form again means change it to mixed radical. So you need to decipher that, understand that question. And it's very important that you identify the roots. So in this case we have roots 3, that means it's groups of 3. So it's 4 times 10, and then that's 2 times 2 times 2 times 5. Again, groups of 3, so identify the group that has 3 of the same numbers, and that's 2 times 2 times 2. Take out one of the members of that group, which is 2, and anything that's left is going to be stuck alone in the cube root. And here's your answer. Now let's try root 26. The index is 2, that means we're looking for groups of 2. So it's 2 times 13. The 13 is a prime number, so is the 2. And it cannot be simplified further because there's no groups of 2's. So basically that is the answer. Root 26 is root 26. Last but not least, root 32, again prime factorized. Now we're looking for groups of 4 members groups. So it's 2 times 16, 2 times 4 times 4, 2 times 2 times 2 times 2 times 2. Now looking for this. There you go. Then we have 4 2's. So again, we take out one of the 2's out, and anything that's left behind will be in the root of index 4, and the 2 is left behind right there. So this is your answer. Just good for good measure, put it in red. Let's take a look at our last examples. In this case, we're going to have a mixed radical, and we want to put it as an entire radical. So we're going to do it backwards. So we have 4 root 3. Identify the power. Pardon me, the index. Well, the index will become the power. In order to bring the 4 back into the radical, we have to take it to the power of the index. So I'm going to write power of the index. In other words, it's going to be square root 4 to the power of 2 times 3, which is 16 times 3. And we could drop the index of 2 because it's redundant. And 3 times 16 is 48. So it's square root of 48 is our answer. And let's do the next one, part B. 3 times cube root of 2. Again, power of index. So we'll have 3 to the power of 3 times 2. And so 3 to the power of 3 is 27 times 2. So the answer is cube root 2 times 27 is 54. And this is your answer. Last but not least, hopefully I have enough space. This is our C. 2 index 5 2 root. So again, we're looking for power of the index. So we have index of 2 of the root. We take 2 to the power of 5 because we have to bring this in, and we have to take the power of the index 5. And don't forget to multiply by the 2 that's remaining. So in this case, we have 2 to the power of 5 times 2, which is basically 2 to the power of 6. And your own calculator, you could calculate 2 to the power of 6 by pressing the right buttons, of course. And the answer is 64. That means root, the index of 5, 64.